I'm going to guide you through the configuration file and point out various things to you. Scroll up and down while we're here. / at the beginning of the line makes it a comment, means it won't be executed. I'm going to skip explaining the data arrays at the moment, except to say that we need a place where we store the data that we read in and from which data will be extracted when we serve it. Now, a gateway has two sides, a client side, or two sides when we think about it. A client side where we're active and we're reading data out of the device, in this case the flow sensor, and a server side where we serve the data to some remote client. In this case we're serving it on Modbus TCP, and we expect there to be a remote Modbus TCP master that will read the data out of us. Okay, so a client side and a server side. Let's look at the client side first. We define a connection and we allocate a protocol to it. In this case, adapter N1 is the Ethernet port. Then we have to define the device we're going to read data from. The name is not relevant, but its node ID is the actual BACnet instance number. We got that information from the BACnet Explorer, and we're telling it to use adapter N1 to go out and read that information. The next section is called client-side map descriptors. Essentially, it's a list of tasks or points that need to be read and how they should be read. In our case, we're reading 2 analog inputs and 3 binary inputs. We got this data from using the BACnet Explorer or the manual for the flow meter. Okay, so there are 2 map descriptors that read analog input 1 and 2, and they store the data in data array called DAF in positions 0 and 1. And because it's BACnet and we're reading analog data, it's reasonable to assume we're going to get a floating point. Okay, we could apply some scaling at the end there. In this case, the scaling is non-effective. We are doing 0 to 100, maps onto 0 to 100, so we're not changing the value at all. Where the engineering units are not relevant because we're just reading a number and serving on Modbus, and Modbus we can't tell it the engineering units. And we're reading 3 binary status points, which we're reading to 3 consecutive positions in a data array called DA status. And if we go up and look at DA status, you'll see it's a bit data array. Okay. Now, Modbus does not know how to transport floating point numbers. Okay. It doesn't have it has a mechanism, but it's slightly complicated. What it does is it uses a special formula called IEEE 754. And that converts a floating point number into 2 16-bit words. Okay, so if I want to give you the flow value, say it's 1.5 cubic meters per second in Modbus, I have to convert it to the special format. Or I could truncate it to an integer and say the flow is 1 until it reaches 2.0, and then I'll say the flow is 2. Okay. In fact, in this configuration, I'm going to do both.